So three properties are one is called, there is no 1 to 3, just I'm talking first, so that is y1. So it is called a reflexive property, reflexivity. It is called reflexivity, and uh, another one is called symmetricity, symmetric property, symmetric or symmetricity property, and another is called transitivity. So transitive property, all, or you can call transitivity. So one relation can be reflexive relation, one relation can be symmetric relation, one relation can be transitive relation. So these are the three things we consider. And there is another one which is anti-symmetric. So that is in between symmetricity. So we will talk about that later. That is not number 4. It is another extension with symmetricity property. So that is called anti-symmetricity. So I will talk about that, no problem. So what I want to tell you, any relation can be reflexive or not reflexive. Any relation can be symmetric or not symmetric. Any relation can be transitive or not transitive. So these are the properties. So we will check one relation whether it is reflexive or symmetric or transitive. So sometimes maybe one is reflexive symmetric but not transitive. Maybe sometimes symmetric transitive but not reflexive. That is possible. I mean, any combination possible. So these are the different types of relations. So before discussing every one by one, let us have some example relations. Okay, let us have some example relations. So I am giving some example relations here. So let me write it down. Say, say uh, based or on, just on the set A equal to say 1, 2, 3, 4, 5. Just one set is given here, and it is 1, 2, 3, 4, 5. The following relations are made on the criteria mentioned. Okay. So let us have different criteria here. Say one, R1 uh, for this criteria. So I'm writing like is greater than. Okay. Another is, I will write this is as R1, and next one is R2. So R2 will be another uh, what is square of, say, this thing. Okay. And C is another, that is again R, maybe R3. Okay, R3 is another criteria is modulo, uh, modulo, say what, modulo 3 of. So I'm putting the numbers here, R1, R2, R3, R1, R2, R3. So the first one will be called R1 and second one will be called R2 and third one will be called R3. So these are the three relations. And based on a certain criteria is given within the quotation mark. Criteria is given within the quotation mark. So say R1. Now I'm just taking this R1. So R1 is a relation here. If you want to show the elements within R, then you have to follow the criteria given. So before that, we need to think what is my cross product of the set. So in this case, it is given on the set. This is a particular term, on. When you see on, that means one set is given, and this is the domain, this is the range. Same thing. So domain, range, same. That means starting set is this A, and the ending set is also A. So the cross product is actually A cross A. So this thing you will understand in the beginning. So what is your Cartesian product? So when you are sure about Cartesian product, then you understand what can be the element inside that. So what can be the element inside that? The element can be 1, 1 or 1, 2 or 1, 3, blah, blah, blah. And again 2, 1 and 2, 2 and 2, 3, blah, 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 like that. And also 3, 1 and 3, 2 and 3, 3, blah, 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 like that. So both of the sets are A, so you understand how the pair will be made. So this is your just understanding. This is your situation interpretation. That's it. So when you are sure about this condition, now you think about R1. So now you think about R1 means what? R1 will have the pairs like what? Now think. Can you have 1, 1 in this R1? You understand my question, my point? Is it possible you have 1, 1 in the relation? Is it okay?
No,
No,
sir.
sir.
No, it is not. Why not? Because it does not follow the criteria. Because the criteria is given like the first number. First number is greater than second number. So it is not the thing. 1 is not greater than 1. So you will check with this. 1 is greater than 1. Is it correct? So if it is correct, then you will take. If it is not correct, then you will not take. So this will be your criteria, and you will check with this, and when the criteria is fulfilled, it is satisfied, then you take this. So 1 1 is not possible. So what do you think? 1 comma 2 is possible?
Yes, sir.
1 comma 2? No, no, no. 1 comma 2 means 1 is
Oh,
greater than,
one
no.
has first one is together. Okay, sir. Yes.
So 1 comma 2
Less than
is
50%.
not also acceptable. 1 comma 4 is acceptable. 1 comma 5, 1 comma 3,
No, sir.
no.
So 2 comma
So
1 is possible.
yes, so
One.
you can, yes, so you can take 2 comma 1. And can you take 2 comma 2,
No,
No,
sir.
sir.
No,
two
sir.
comma
It's not.
three?
No,
No.
No,
sir.
sir.
You can take 3
Yes,
comma
sir.
1.
Then okay,
3, 3, 2.
so 2 comma 1 is acceptable. Then finish. Then go with 3. So
Yes, sir.
3 comma 1 is acceptable, and 3 comma 2 is acceptable, and 3 comma 3, 3 comma 4, 3 comma 5, these are not. So you start with 4. Then you write what? 4 comma 1 possible, and 4 comma 2 possible, and 4 comma 3 possible. And 4 comma 4, 4 comma 5, 4 comma those two, 4 comma 4 and 4 5 are not acceptable. Okay, so 4 comma 1, 4 comma 2, 4 comma 3, these are okay. But if you think about 4 comma 4, it is not. It is not. So go with 5 now. So what you can get for 5? 5 comma 1 possible. 5 comma 2 possible. 5 comma 3 possible. And 5 comma 4 also possible to take in R1. So that is all. This is the end of relation R1. Okay, is that okay? Any confusion or any question?
No, sir.
Okay, so this is the relation R1, and we have the elements within R1. Now, in the same pattern, in the same way, you make the relation R2 and tell me who are the elements in R2. So that is another relation R2, and it will be again the subset of A cross A, and it will be based on the given criteria. Criteria is square of. Now you tell me who are the elements.
Sir, 1 1.
1, 1, 2,
Yes,
4,
one
2,
is
4
4.
2. 1 1 or 4 2.
Yes, sir. 4, 2.
so one. One is okay. One is okay because you again check the criteria. Criteria is what? Criteria is 1, then you put the criteria. What is that? Is square of 1. So is this okay? Yes, it is okay. 1 is square of 1. So we are taking this. If you think about 1 is square of 2, is it possible? No.
No, sir.
1 is square of 3, is it possible? No. 1 is square of 4, is it possible? No. So we are not taking 1, 2, 1, 3, 1, 4. And you can again check with another number, say 2. So what you can say? 2 is a square of 1, is it possible? No.
No, sir.
2 is a square of 2, is it possible? No. So 2 is a square of 3, is it possible? No.
No.
So we are not taking 2 is a square of 4, 2 is a square of 5. It is not correct. So we are not taking anything with 2. And in the same way, 3 is a square of 1, 3 is a square of 2. You will check like that. And then if it is okay, then you will take it here in R2. So actually we will get another one. 4 is a square of 2. 4 is a square of 2. It is correct. And no else, no other elements. Just like that. So this is R2. Is that okay? Is that correct?
Yes, sir.
Any any question? Now I will go to the third one. Third one, I have to make a little correction. Uh, Let me just write it like that. Another word. It is called congruent. Okay, I'm putting the word in between. The word is congruent. So it should be written like is congruent modulo 3 of is congruent modulo 3 of. So let me write it down. The word R3 will be the relation with this criteria. What is that criteria? Congruent. The criteria is called congruent modulo 3 of. So I will explain this now and then you will understand. So what is congruent modulo 3? Congruent modulo 3. Congruent means same, similar. Okay. So what is the meaning of this? Actually here the meaning is the numbers which will give you the same result uh, for modulo 3. Same result for modulo 3. So let me just uh, show you something. Say what is 1 modulo 3? If you think about modulo operation, you already know what is 1 mod 3. What is this value? 1 mod 3?
So one.
It is 1.
It's one.
And then if I write 4 mod 3, then what will be the answer?
One.
One.
That is also 1. So if you see, the answer is same. If you take 1, then 1 mod 3 equal to 1. If you take 4, then 4 mod 3 equal to also 1. So we call 1 and 4. 1 and 4 are 1 and 4 are congruent. They are congruent because they are giving you the same result. In this case, they are giving you 1. So what is the congruent meaning? It should be now clear. Do you understand this? Let me give you another example. Say I am writing 2 mod 3. So what is 2 mod 3? This is 2. What is 2 mod 3 answer?
2, sir. 2.
It's 2. So if you take 5, then what will be the answer? 5 mod 3.
So again two.
Again 2. So we are taking mod 3 fixed because it is given here mod 3. Modulo 3, it is given in the question, it is fixed. So we will consider modulo 3 every time. If I give modulo 4, then you will take modulo 4. If I give modulo 5, then you will take that. So when we take 2 as the original number and then apply mod 3, then the result is 2. If I take 5 as the original number and mod 3, then result is same. So this is also 2, this is also 2. Then we will call 2 and 5 are congruent. We will call 2 and 5 are congruent. So congruent, when they are congruent, if we consider mod 3 operation, that is correct. So if it is mod 4, then maybe different, but congruent modulo 3. This is called congruent modulo 3. Is it okay? Do you understand now? If it is okay with your idea, then you can think what will be the elements in R3. What could be the elements in R3? Now you tell me, what is the elements in R3? Can you take 1, 1? Yes. Why yes? Why yes? Because you will try like this one first, 1 mod 3, and also the second one, 1 mod 3. So do you find the same result? Yes, you will find the same result. 1 mod 3 is equal to 1 and 1 mod 3 is equal to 1. So they will give you the same answer. Isn't it? Do you understand my point? That is why they are congruent. That is why 1, 1 can be taken. So what about 1, 4? Yes, possible 1, 4. Why possible? Because 1 mod 3 and 4 mod 3 are the same answer. Is that okay? Can you take 1, 3? No. Can you take 1, 5? No. Because they will not give you the same answer. Is that okay? Not correct, not clear.
Okay, sir.
So we are not taking 1, 3. Why not taking? We are not taking this. Why not? Because 1 mod 3 and 1 mod 3 and 3 mod 3, they are not same result. 1 mod 3 is 1 and 3 mod 3 is 0. So they are not congruent. So they are not giving you the same answer. So we are not taking 1, 3. Is that okay? Clear? Now tell me what should be the next pair. What should be the next pair? 1, 4 is okay. Then what is the next pair?
So 2, 2.
2, 2. Correct. 2, 2 can be taken. 2, 2 can be taken. So let me just write it down. 2, 2 possible. Yes. Then 2, 3 is possible.
No, sir.
2, 4 is possible.
No, sir.
2, 5
2,
is possible.
5.
And then
Sir, that's it, sir.
no more 3, 3, 3.
Sir, no, sir. That would be the 3, 0. So
Yeah. So what is the problem? They will give you the same answer.
Yes, sir. It's can possible. They give the same answer, but can we
3
write it?
is
separate?
the.
Yes. Yes,
Sir,
we can write.
so the modulo of 3 is 0.
Yes, 0 and another 3 modulo 3 is also 0. So they are
Oh,
the same answer.
oh, sir. Oh, sir. I was thinking like one has to be the answer and other. Yes, sir. I guess.
No, both are same. Both
Yes,
are
sir.
same answer. So possible. Okay, this is also 0. That is also 0. Fine. Same answer possible.
Yes, sir.
That is the understanding of congruent. Okay, now think about any more any more pairs. 3,4, 3,5 possible? No. What about 4? What about 4?
4-1.
4,1 is possible. 4,1. So this is taken, and 4,4 is also possible. So it is taken. And 5,1, no, so 2, it is possible, and 5,5, that is also possible. So these are the elements in R3. These are the elements in R3. Okay, so these are the elements in R3, and based on 3 given criteria, one is greater than, another is square of, another is congruent modulo 3. So in the exam also, I can give you some of the conditions like that, and then I will tell you, check which property is held by the relation, which property is satisfied by the relation. So your duty is to check with the reflexive property and transitive property and symmetric property for R1, for R2, for R3. So R1 we need to check. Maybe it is reflexive or not reflexive, maybe it is symmetric or not symmetric, and maybe it is transitive or not transitive. And in the same way, for R2, you will also check it may be reflexive or not reflexive, symmetric or not symmetric, transitive or not transitive. Okay, and in the same way for R3. Is it okay? You understand the situation? The situation is clear now. Now I will explain what is reflexive and how can you check this. So that thing I will now explain. But before talking about that, is that okay? Do you understand the situation? Is that okay? Can I start talking about the properties now? Can I start talking about reflexive property and
Yes, sir, you can try.
okay. So let me talk about reflexivity first. So how you can call one relation as a reflexive relation. How you can say that. So you need to check something. Mm, for all elements in the domain, okay, for every element, let me write every element, every element A, or let me write X in the domain. X in the domain means X in the domain means the first set. first set and second set both are A in this case, but anyway, commonly we can say domain. That is the first set. So for every element X in the domain, there will be X comma X in the relation. Okay, let me write in R. So the symbol is, you already know that this is the symbol that is called, is a member of or belongs to, right? Is a member of or belongs to. This is the symbol, and you can use that. X comma X is a member of R. R means the relation. R means the relation. So if it happens, this is the condition. If it happens, then you will say the relation, then we call the relation R is reflexive. Relation R is reflexive relation because it holds the reflexivity property. That's all. So this is the understanding. Now you understand what is R. R is the relation. So the relation will be called reflexive if this condition or this criteria happens. So you can think about the elements what you have in your domain. What is the domain? Domain is our A. In this example, domain is A. So what are the elements in that? Elements are 1, 2, 3, 4, 5. So if you have 5 elements, for everyone, you need to check X comma X. X comma X means what? 1 comma 1. So you need to have 1 comma 1 and also 2 comma 2 and also 3 comma 3 and also 4 comma 4, 5 comma 5. For everyone, you need to have a pair like that, 5 pairs like 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5. If it is available for everyone, then you can say the R is reflexive. That is, relation is reflexive. So in this example, which one is reflexive? You got my question? In the example on right side, R1, R2, R3, which one you can say reflexive?
Sir, if for every X is it has to be true?
Yes, this is the
Sir,
condition for every.
R3, sir.
R3. R3 is reflexive because you can see 1, 1 is there and 4, 4, 2, 2, 3, 3. Everyone is there. So it is reflexive. So R2, is it reflexive? No, because only one element is present, but not everyone. So this is not reflexive. R3 is only reflexive. And R1 is also not, because 1, 1, 2, 2, they are missing. So this is called reflexive property. Is that okay? Do you understand that? Now let me tell you quickly about the symmetric property, and maybe
Sir,
I need to explain. Yes.
R3 is reflective just because all the elements are present here, right?
Yes, every pair like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. I mean, if you have 5 elements in the domain, you need to have 5 pairs. Every single pair you need. So in this case, only R3 is reflexive. So that is all. Let me write the symmetric property. okay, quickly, and maybe I will describe this thing again. Symmetricity property. So what happened with that? Uh, for every pair, every pair like x comma y, okay, in the relation. So in the relation, I will just use that symbol. There will be uh, y comma x. Okay, in the there will be also y comma x in the relation. So then we call the relation as is symmetric. Yeah? So okay, and if no such y comma x is present, then the relation is called as anti-symmetric. So that is the second point. Now let me explain and check with the uh, example here. So this is a member of symbol, and this is a member of symbol. So what is actually here? If you have x comma y means if you have 2 comma 1, x comma y means 2 comma 1 or 3 comma 1 or 3 comma 2. So if you have 2 comma 1, do you also have 1 comma 2? That is the condition you will check. So if it is, then it will be symmetric. Say there is 4 comma 1. So do you also have 1 comma 4? So if not, then not symmetric. So here also you will check for R3. You have 1 comma 4. So do you have 4 comma 1 also? Do you have 4 comma 1 also? Yes. Yes, you have, right? This is the thing. So you have 4 comma 1 also available. If you have 2 comma 5, then do you have 5 comma 2 also? That is your question. Do you have 5 comma 2? So you will check and find it out. Yes, it is available. So 5 comma 2 also available. Do you understand my question? But
Yes, sir.
in R1, it is not available. Not available, not available. What about R2? Is it available? No. 4 comma 2 is here, but 2 comma 4 is not in the relation. So we cannot say R1, R2 will be reflexive. So R1, R2 will not be reflexive, it is true, but there is another condition, another thing, that is it only not reflexive, or should it be, not symmetric, or should it be anti-symmetric also? So what is anti-symmetric? Anti-symmetric in the situation there is x comma y, but there is no y comma x. So actually R1 and R2 both are antisymmetric, because if you have something available and some others are not, then not symmetric. And if you have no opposite, no reverse element available, that will be called antisymmetric. So in that case, R1 and R2 both are antisymmetric, and R3 is symmetric. R3 is symmetric. Okay, you got my point? So let me just tell you another one, transitive property, quickly, and then we will discuss all these again with some examples tomorrow. So that will be clear. So another property is transitivity property. And what happens with this? Uh, uh, for x comma y and y comma z, okay, both in the relation, okay, there will be x comma z also in the relation. So this is the thing, and we call this we call this the transitive relation. Okay, then we call the relation as transitive relation. Okay, so that is the third property. Okay. So what is actually happening here? In fact, it is something like hypothetical syllogism. Anyway, so x, y, y, z, x, y, y, z. So x, y, y, z, this is our two pairs. So two pairs like x comma y, y comma z. So there will be something like, say, 3 comma 2. Let me just use another color here. Any combination, first, second does not matter. Any combination, any way you can check. So let me just think about 2, that is pair. One is 3 comma 2 and another is 2 comma 1. So I'm talking about first one as x comma y. X comma y is 3 comma 2 and y comma z is 2 comma y comma z means 2 comma 1. So we are thinking x is 3, y is z, and y is 2 and z is 1. So you will look for, if these two are the pairs, then you will look for the third one. You look for the third one means what? X comma z. So x comma z is actually the third element. Actually it is 3 comma 1. So do you have 3 comma 1? That is your question. I have 3 comma 2 and 2 comma 1, two pairs, x comma y, y comma z, and then I will look for the third pair, that is x, z. So in this case, it will be 3, 1. So do you have 3, 1 here?
Yes, sir.
Yes, there is 3, 1. So this is transitive. And not only one example, you can check with any other. You can check with any other. Say 4 comma 3. Okay, I'm now talking about 4, 3. 4, 3 and 3, 2. So if it is 4, 3, 3, 2 pair, then what will be the third one? 4, 2.
Okay.
Is it here? Yes, it is here. So this R1 is transitive. So R2, is it transitive? No. R3, is it transitive?
So 1, 4, 4, 4, 4. So yes, it can be transitive.
Yes.
Yes.
So R3 is also transitive. So that is all for today, and time is up. We will discuss about the properties again
Sir,
tomorrow with some other examples. Yes.
so one thing, like if I find only one transitive relation, then that's enough to call it transitive.
No, you have to find everyone. For all X, Y, and YZ kind of pair, there should be the third pair. All cases. You have to check everyone. So
Oh,
we will discuss about that. Okay, how can you just check this? Because one set may be very big. So how is it possible? So we will talk about that. Okay.
okay, sir.
So that is all for today's class. So take care and bye bye and
Okay, sir.
Okay, sir. Bye, sir.